Hello, and welcome to this course in which we're talking about using pythons and decoys for active defense. In this video, we're going to be talking about using decoy processes to achieve active defense objectives. And so a decoy process is pretty much exactly what it sounds like. It's a program that's masquerading as something else. And decoy processes are programs that can be applied to a variety of different active defense use cases. So, one application of a decoy process is to create artifacts that direct attackers to decoy systems. So, for example, we might have a process that visits a website that's a fake or decoy website designed to distract an attacker or learn about their TTPs for compromising web applications. And so if we have this fake process that's designed just to look like a legitimate user using a legitimate site, that helps to distract the attacker's attention and send them targeting decoy content rather than the real thing. Alternatively, we could use a decoy process to pretend to be SSH connections to a decoy computer on the network, etc. So just creating evidence that certain things happen normally on a system, like accessing other systems that happen to be decoys. A second use case is trying to make a system seem more vulnerable or enticing to an attacker. And so when an attacker is trying to decide what systems to target, there's two important criteria that come to mind: how easily they can get into the system and whether or not the system's worth their time. And so from an how easily they can get into the system perspective, having systems that are pretending to be vulnerable applications can help that system seem more enticing or inviting. So, for example, it's common to perform some level of network scanning or vulnerability scanning of a system to identify potential weaknesses. And so if you've got a decoy process running on the system that claims to be a vulnerable version of an application and responds correctly to that network or vulnerability scanning in line with how that application would respond, the attacker might think, this is an insecure system that I can target and I can exploit this vulnerability, and waste time trying to break a completely different process than what's there. Alternatively, the processes running on a system might make it look more inviting to an attacker. For example, if you have something like SQL or other database software running on the system, there might be the belief that this particular system contains sensitive or valuable information stored within a database. And so having a decoy process masquerading as an SQL server could draw attention to the system and motivate the attacker to target it. And then thirdly, a decoy process can help to influence an attacker's behavior based on the processes present on a system. So, for example, it's not uncommon for malware to try to evade defenses, either by hiding itself from things like antivirus or by taking action specifically to eliminate or disable these protections on a system. And so if you have a process that's masquerading as an antivirus, it could either cause malware not to run on the system because the malware believes that the system's protected, or it could cause the malware to act against that process, revealing its presence on the system. And so we see here at the bottom that one of the procedures for this particular MITRE shield technique is to create decoy processes that mimic common antivirus process names. And then again, these can help cause adversary malware to not execute or to take action against that particular process. So in the next video, we'll look at the development of decoy processes using Python that are designed to detect malware that takes action directly against an antivirus, by trying to stop it from running on a system. Thank you.